This is Algebra Lesson 4.1a. Here's the warm-up question. And our objectives today are to solve real-world problems involving the slope of a line and using graphs to calculate slope using slope triangles and the slope formula. Also identifying the slopes of falling and rising graphs, horizontal and vertical lines. So in this first example, we're going to look at calculating the slope based on the slope triangle. So with the slope triangle, you're just going to pick 2 points that are actually on your line, and I would advise you to pick points that lie nicely on like specific coordinates, not partial coordinates. So here's a point that crosses nicely, and it looks like maybe this one crosses nicely here. So now I'm just going to do a rise and a run. Now I could have picked 2 other points anywhere along this line, but I'm going to connect using my rise and my run, and then I just calculate how far up and how far over. So 1, 2, 3, 4, 5 for my rise, 1, 2, 3, 4, 5, 6, 7 for my run. So my slope here is going up 5 over 7. So this would be 5/7. Now if I had picked a larger triangle, it would be the same slope, but it might be a non-reduced fraction of that version. So you can reduce them and get this equivalent fractions even if your slope triangle is different. On the next one, if I pick, let's see here. These are a little bit hard to see. This one looks good. And maybe this one right here, that one looks pretty good. So I'm going to look for my rise and my run there. And if I connect those, notice my line is going down, so my rise is actually going down, which means it's a negative number, so that's -2 down and 1 over. So my slope is -2 over 1. And this one I can reduce just to -2. Either answer is correct, but it's rise over run. So the slope of this red line is 5/7. The slope of this purplish line is -2. Alright, now we're looking at slopes of horizontal and vertical lines. So remember, we're looking for a rise and a run. Now looking at this one, the rise is nothing. So if I pick 2 points on this line here, I'm not going up at all to get to the next point. So my rise is 0. My run, in this case, is 3. So if I do 0 over 3, the answer comes out to 0. So this is a rise of 0, a run of whatever 2 distances you have, or distance you have between the 2 points, but the answer is always going to come out to 0 because of the 0 on the numerator. Now in this case, when we have a vertical line, I do have a rise. So let's say I pick this point here and this point here. I have a rise of 3 in that case, but I don't have any run. So 3 divided by 0 comes out to undefined. So anytime that you have a vertical line, the slope is undefined. Now if I wanted to write the equations for these lines, they're a little bit different than the normal mx plus b equation. So this one, because it's crossing at a y-intercept of 3, and it's got the slope of 0, the equation for this is just y equals 3. In this case, it's got an x-intercept, 1, 2, 3, 4, 5. This x-intercept right here is the value -5. So that's going to be x equals -5. We don't use a y equals equation for a vertical line. Alright, in the next example, we're going to look at calculating the slope using coordinate points. Now you could still graph these points and then do the slope triangle. That will work as well. But there's also a formula that will work. So first let's graph these points. So I'm going to go over 4, 1, 2, 3, 4, and up 7, 1, 2, 3, 4, 5, 6, 7, right at the top here. So that's this point. And then I'll do the next one in green. So I'm going to go left 7, 1, 2, 3, 4, 5, 6, 7, down 2. And then I would connect those with a straight edge. And I would be looking for the slope that is my segment here, or my line if I made it a line. Now again, you can count rise and run. And if I counted these, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a rise of 9, and my run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my slope would be 9/11. Now there is a way to do that using the coordinates. So this would be x1 and y1, meaning my first coordinate point. This would be x2 and y2. And what we're doing when we count our rise is we're finding the difference in our heights, the y's, and when we find our run, it's the difference in our x's, the run. So we're going to do the formula y2 subtract y1 over x2 subtract x1. This top part, or the numerator, is how far up it goes between the 2 points. The denominator is how far over it goes. So if I plug in these values here, it will come out to the same answer as 9/11. Sorry. So my y2 is -2. The formula says subtract. My y1 is 7. My x2 is -7. The formula says subtract. And my x1 is 4. And if I work this out, this comes out to -9 over -11. And you're saying, well, wait a minute, that's not the same. But remember, when you have a negative divided by a negative, they cancel out to be positive. So I do get the exact same answer as before. So here my slope is 9/11. Now in this next problem, you could do the exact same thing where you could plot it and figure out the rise and run. You could also do the slope formula. So I'm going to practice plotting it first. So over 4, down 6, and over 2, up 6. And then I would connect those to make my segment. And I could count my rise and my run. Now if you notice, in this case our rise is going down. So 2, 4, 6, 8, 10, 12 down, and 2 over. So this slope should be -12 over 2. Now you can reduce this. -12 divided by 2 comes out to -6. These are equivalent, they mean the same thing. You could also plug this into the formula and find the same answer as well. So the equation for finding slope again is y2 minus y1 divided by x2 minus x1. And I just want to remind you that you have to solve the numerator and the denominator before you do the division. So here we want to use the slope formula in finding them. Now this problem here was the exact same one as we did before. So let's try this one here. So I'm going to label these as x1, y1, x2, y2. And then when I plug it into the formula, y2 comes first. We have a minus sign in our formula, and y1 happens to have a -6, so I do need both of those symbols. x2 is next, which is number 2. Subtract x1 is the value 4. 6 minus -6 comes out to 12. 2 minus 4 comes out to -2. And when I simplify this, it does come out to -6, which if we rewind and look at that answer down below, we had the exact same answer for that exact same set of points. Alright, in this next example, we're using an actual real-world problem to find the slope, talking about the rate of change. So here it says, this is when we used to have to pay for internet usage based on the time that we spent online. So we're going to graph this set of data, and then based on the graph we're going to find the flat monthly charge that Wanda has to pay no matter how much time she spends on the internet. So I'm going to do that right now. Why don't you pause the movie and take some time to graph yours as well. Alright, after taking some time to graph my data and connect the dots, here's the line that I came up with. I did label my axes, so I have time at the bottom, money on the side. And if I look at the 0 amount of time spent, how much is she charged just for her monthly rate? I'm going to look right here at 0 minutes, or 0 hours, sorry. And the height here is approximately $5. Now, the name for this point, because it's on the y-axis, is called the y-intercept. So Wanda's charged $5 no matter what amount of time that she spends on the internet. Now, if we wanted to use this to calculate the rate of change for her month or her hourly rate, you could do the rise and run here. Now on the graph it's a little bit harder, so you might want to use that with these two sets of data here. Now I just picked 2 on the table. You could do any 2, but these would be your y's and these would be your x's. So think of this as y1, y2, and x1 and x2. And you would follow the same slope formula to figure out how much she pays per hour for her internet usage. All right, in example D, we're talking about Fred scaling a steep incline, and it takes 20 minutes, 20 minutes into his climb, he's at an altitude of 30 feet. So we'll put that here, 20 minutes, 30 feet. And then at 45 minutes, he's at an altitude of 95 feet. What is the slope or average rate of change, and what does it mean? So all I'm going to do is transfer my points into coordinate points, and then follow the slope formula. Remember the slope formula, y2 minus y1 over x2 minus x1. And why don't you take a time, pause the video and try this out on your own. See if you can get the right answer. After using the slope formula, I calculated out my slope to be 2.6. Now, what does that actually mean for this particular problem? So looking at this is 2.6. That would be the result of this fraction. That fraction is the number of feet over the number of minutes. So this is 2.6 feet in altitude that Fred is climbing per minute. Example E is about the same type of question. It says when Jenny was 10 years old, she weighed 80 pounds. And now at age 14, she weighs 120 pounds. What is the rate of change and what does it mean? So take a moment to pause the video and try this problem out to double check your answer. Now in this case, once I plugged in my formula into the slope, or the points into the slope formula, I come up with the answer of 10. Now we were looking at weight and age. Now because weight is our rise, that was on the top, age is on the bottom. So this means that Jenny gains 10 pounds per year of age that she grows. And this will be the practice that we use for this problems.